maximize velocity, minimize risk. With Coverity, these are not mutually exclusive goals. We help developers write better software. That means finding and fixing problems early and helping developers do a better job of testing what they've written. We help QA focus testing on what matters. That means understanding what has changed so testers can intelligently schedule tests and understand which gaps need to be filled. We help security reduce security vulnerabilities. That means enabling developers to find and fix security problems during development so security audits go smoothly. We help managers make better decisions. By understanding what's happening throughout the development process, code intelligence equips managers to anticipate problems and keep projects on track. Maximum velocity, minimal disruption, code intelligence. It's not about testing more. It's about testing smarter and testing faster. Coverity Test Advisor QA Edition specifically helps QA teams stay ahead of the release curve. Don't waste time testing functionality that hasn't changed. Test exactly what needs to be tested by understanding the impact of code changes. Don't let bugs slip through. Identify and plug testing holes by understanding which code is being tested across the SDLC. Don't get caught off guard. Understand the impact of code changes before you make them, so you know if they will jeopardize the schedule. Don't guess. Know exactly how well you're testing so you can confidently release. Coverity Test Advisor QA Edition is a hybrid cloud solution. Just install the local agents and plugins on your local network and you're ready to plug and play. There's no need to change your build or testing infrastructure, and it doesn't matter if you use automated or manual tests. All of your source code, binaries, and application data stay on your systems. After capturing the testing artifacts locally, securely upload them to our cloud servers for analysis. Access the testing cockpit from the cloud to understand how well you're testing your applications. It's easy to download testing strategies for optimized testing runs from the cockpit, ensuring that you don't waste time running unnecessary tests. Now let me show you what it might look like with a web application. When you run a test, we're able to capture that test's footprint onto the machine where you launch the test. All of the information is captured on the local machine to be uploaded to the server for later processing. Many tests are run manually from a web browser, so we have a browser extension to make it really easy. All I have to do is enter some information about this test and start the capture. In this case, I'm going to run manual test number 12 to verify that the page calculates the discount correctly. I click Start and the system starts capturing this test footprint. Now I just go through my testing steps as usual, and the system will monitor what's going on. Not what I, the user, am doing, but what the application code is doing in the browser and on the server. My test instructions state that I should add a clearance item to my cart and verify that a discount has been applied. Good, there is a discount. Now that the test is finished, let's see what the system has done. Here you can see all the web requests that have happened since we started recording, as well as all the web resources used by each. We can also see the coverage included in the footprint. We're looking at the footprint in terms of the JavaScript here. And if I want to see which parts use the shopping cart, I can search for cart item. In this case, we only have a couple of JavaScript routines. If a developer changes this code, it will impact this test. And this footprint makes that connection so that we can report it. We can do the same thing on the server side. Here we see all the code that executed on the server while running this test. We can search for the methods pertaining to the discount calculation. Just like with JavaScript, we understand that if a developer changes server code that impacts the discount calculation, it will affect this test, and we can report that. Since I'm done with the test, let me stop the capture and indicate that it was successful. Now the test footprint is stored on my system with all the details about what was going on. You can upload these footprints to the cloud periodically, perhaps once a day, with all the data, and it will be analyzed and made available in the cockpit. Now let's switch gears. We're no longer recording tests on our testing machines. We're reviewing the testing intelligence in the cockpit. Now we're looking at the cockpit, which is the most useful part of the system. Capturing footprints is good, but it's really just collecting data. The cockpit is where you learn interesting things from that data. Let's start in the dashboard. These circles represent how well we're testing. Let's focus on the red one, which represents all the code which was modified in this release. The light green circle represents all of the footprints from the build tests, the tests run on the development side, like unit tests or integration tests. The dark green circle is the functional tests, typically run by QA. Some tests might be automated, but they're very often mostly manual tests. What we see here is that some changes have been touched by tests, but the fact that we can see red indicates that other changes have not been touched by any tests. That information is available in the coverage bars at the top of the page as well. The dark blue box represents the modified code that has been tested. The light blue box represents the modified code for which tests exist, but those tests have not been run. That's a clear case of not running the appropriate tests for the changes made. The light gray box represents the modified code for which there are no known tests. That's what we'll call the testing gaps, or holes. To address the former, we help you prioritize your tests to ensure you run exactly the right set of tests for the changes made. Specifically, you should run the tests that exercise the code that changed. This list contains all of those impacted tests. We can investigate the full details about each test, including which code is exercised and which code was affected by the modifications, which explains why we recommend running the test. Rather than sifting through those tests manually, many of our customers utilize our test scoring wizard. They can easily export the list of tests and scores, then use tools like Excel, HP tools, or even scripts based on priority, filters, and so forth to build a list of tests to run. That testing strategy can be used with tools like HPQC and ALM to run exactly the necessary tests. For users that don't want to drive things manually, we also provide automatic strategies. Say you have a hotfix that you need to deploy to production quickly. You can easily determine that you need to run these 2 tests for a really fast minimal validation, or you can run these 3 tests for a more secure validation of the changes introduced in the hotfix. Now that we know which existing tests to run, let's talk about how to identify the gaps or holes. You may recall this box, which represents the modified code that has no associated tests. The goal, of course, is to add either development or functional tests for this code. For users that do not spend significant time in the code, such as analysts and testers, we provide what we call a business view. This describes the application in terms of business functionality, as opposed to the code architecture. This is strictly optional, and in fact some users do not use it at all. Most do invest some effort to create at least a partial business model. This is actually one of the only areas of the product where you need to do some configuration. I want to see how well we're testing these modules in terms of the modified code. In this view, all of the gray areas were not touched at all by the code changes. The yellow boxes are the modules that are fully or partially tested, and the red boxes represent the areas with changes that have not been tested. Each of these modules has been assigned a criticality, so we know how important it is to test. While neither shipping nor notification is tested, we can see that shipping is more important to test. That's where we want to add new tests. To see exactly what needs to be tested, we can look at the test coverage details. By focusing on the untested, modified code, we can really tell where the changes were made and what is not being tested, both at the method and class levels. This equips the QA team with specific data that they can use to collaborate with development to ensure all the important code is tested in terms that developers understand. And it's not just a simple list. When we have data about a test, you can drill down into the knowledge base to understand what's happening in the code. For example, we can see that this class is covered by 17 tests, and this one has 1 test. We can actually drill down to learn more about those tests. The last thing I will introduce is what we call our impact simulator. This is a popular tool that leverages our testing intelligence and enables you to explore the impact of code changes before you actually implement them. This is especially useful, for example, to forecast the validation burden of a proposed change. For example, say we're considering changes to the payment module. By selecting the payment module, we get a list of all the code in that module. Assuming that we change that module, we can see that we will have to run 40 tests, which takes about 12 minutes, and we'll have 126 testing holes that should be filled. You can also work from the source objects rather than choosing a business module. For example, say we plan to make changes to the workflow classes. We can see all the elements that will be impacted by those changes and see that we will need to run 2 tests taking 36 seconds. And we can drill down to see which specific tests need to run. In this case, T38 and 39. Developers can really leverage the simulator to understand the impact of potential changes on QA and the release process by understanding the testing effort it will require. This has been a brief demo, but hopefully it helps you understand how our solution can help you improve the effectiveness and efficiency of your testers by helping them run exactly the right tests to validate code changes and add tests that plug existing testing gaps or holes. It works with automated and manual tests, whether those are run in development or by parties that are not familiar with the code. To better understand how the Coverity platform can help you improve your testing efforts, please visit our website. Don't hesitate to request a trial if you'd like to try it out for yourself.